Hello students, today I am going to deliver a lecture on the topic of dropout. In that lecture, we will discuss the need of dropout and and the and the advantage of the dropout on a neural network. So students, we all know in a neural network, uh, problem of overfitting comes whenever we do training on a very small data set. And due to this overfitting, uh, the accuracy of the model will be very low and results will be very poor. And that overfitting we also call the generalization error. Okay. And here I explain the concept of overfitting or underfitting by the help of graphs. In the upper row, the graphs are representing the training, whereas in the lower row, the graphs are representing the testing. In the upper row, three graphs are given. The first graph is representing the case of underfitting. The second case is the good balance of under and overfitting. And the third case is the case of overfitting. So you can see in the first case, the model is not trying to reach any point. It is moving in its own direction, whatever the data is. Means we can say that the model is having a high bias, means the model is highly biased. It is moving in its own direction. The data, whatever the data is, it doesn't matter for the model. This is the case of underfitting. Okay, because the model is not trying to fit any data. Whereas the third case, you can see the model is trying to reach each and every single point, and it is trying to reach to very high extent. This is a case of overfitting where the variance is very high and the bias is very low because the model is not going in its own direction. Here the model is going towards the points. So here variance is very high. Okay, and this is the problem of overfitting because whenever we test the model on a data set which is slightly different from the training data set, and you will observe that the accuracy will be very poor. You can see in the lower row, the third graph, the case of overfitting, that the red dots are representing the testing data set. So you can see here the model, the function of a model is not reaching from the testing data points. So that is why we get the low error, high amount of error and the poor performance at the testing time. But you can see in the middle case, in the upper row, that the function is very much general. It's not trying to reach every single point, but it is moving between all those points. And you can see at the testing time, the accuracy is will be higher than the case of the overfitting. Okay. So what our objective? Our objective is to make the overfitting function to a very general function, means the middle case, like middle case. Okay. So we want to make our overfitting function a general function. So what's the solution? The one of the solution is to provide training the different neural networks on a same data set, and the every neural network will learn on its own way and overfits in different ways. Okay, every neural network will overfit in a different manner, and at the end we take the solution, we take the average of all neural networks as the output. So this will also give a general solution, right? Because we are taking the average of all different neural networks. But if you look at the practically, this is not feasible because if we provide training so many neural networks and on a large data set, then it is very time consuming and not feasible for us. So another solution is the dropout. Dropout do the same but in a very different manner and makes it so feasible. What we do in dropout, we in an every iteration of in every training iteration, we make a neural network a different neural network by the help of dropout. In dropout, we drop out some neurons from a network, and the neuron after dropping out, the neural network will become a new neural network and will become different from the neural network of other iterations. As you can see in the below given graph, the gray nodes are those that are dropped out from the neural network. Here two neural networks are given. Actually, the neural network is same, but they are different because the dropouts are different. Okay, in every iteration we drop out the different neurons. So that is why the same neural network will become a new neural network, a different neural network. Okay. So after dropout, the neuron doesn't compute anything, means doesn't take any input, and doesn't transfer its output to the other neuron. Now question arises how to drop out. For dropout, we fix a probability P for every layer of a neural network. On the basis of probability, we drop out the neurons from a network. And the second thing, the dropout can only be done on the visible layer, means the input layer or the hidden layers. Okay. Dropout we never do, we never apply on the output layer. So our new hyperparameter will we will see in a neural network or in a dropout, which is the dropout rate. The dropout rate for the dropout rate actually decides the how many neurons must be drop out from a layer, and it always will lie between 0 and 1. If the dropout rate is 1 means no dropout, and if the dropout rate is 0 means no output from the layer, means all neurons will be dropped out. A good value for dropout in the hidden layer is lie between the zero point 0.5 to zero point 0.8, and for the input layer it will be zero point 0.8 and or the other. So that's all for the today's session. Thank you.